First thing we have to do when we start with this is to recognize the relationship between the zeros and the factors. So if we know a 0 is 4, then we know that one factor of that polynomial has to be x minus 4. And why is that? Well, if you plug in 4 for x, 4 minus 4 gives us 0. All right, and so once we know that one factor is x minus 4, and now that we know polynomial division and synthetic division, we can divide quickly to bring this down to a polynomial that we can factor much easier than the way it's written. So let's do synthetic division because it's faster. So first, this is x minus 4, so then in that little box on the outside we'll put plus 4, always the opposite sign. And then the coefficients are 2, 3, negative 39, and negative 20. All right, notice there's no spaces I have to worry about placeholding because it goes 3, 2, 1, 0 right down the line. So then for synthetic division, the 2 just drops straight down. 4 times 2 is 8, which that makes 11. 4 times 11 is 44. So again, we're adding. So this becomes 5, and 4 times 5 is 20, which leaves a remainder of 0, which is perfect here because this wouldn't work otherwise. And so we know now we're dealing with a polynomial 2x squared plus 11x plus 5 equals 0. So now to find the other zeros, I can either factor or use the quadratic formula or complete the square. I'm going to factor this one, and I'm going to factor it using the box method. I don't know if you learned this one, but if not, I'm going to show you a way to do these. There's also the T method, and there's also guessing and checking for these. You use the one that you feel most comfortable with. So the first thing for the box method that you do is you multiply the first term and the last term. So 2x squared times 5, and that's 10x squared. And now I need factors of 10x squared that add to the middle term of 11. And so in this case, that would be 10x and 1x. 10x plus 1x is 11x. And then what I do is I draw a box, hence the name. In the upper left corner always goes the first term, so 2x squared. In the bottom right corner always goes the last term, 5. And the other two boxes are reserved for these two things, and they can go in any order you want. It doesn't matter. I'm going to put 10x here and x there. Do not worry about the signs at this point. You can finish the signs off later. And then what I'm going to do is I'm going to take the GCF of each row and each column in the box. So here, between 2x squared and x, the greatest common factor is x. And between 10x and 5, the GCF is 5. And now as I go down and do the columns, 2x squared and 10x is 2x, and x and 5 is 1. And then basically what I've created are the factors of the polynomial. So this polynomial factors into that. Now, what's missing? The signs. Well, how do I put the signs back in? So what I can do is I can look at each part. And so 5 times 2 gets me 10, and I know that the 10x has to be positive, so the 5 has to be positive. And x times 1 gets me 1, and the 1 also has to be positive, so that has to be positive as well. I know since all the signs were positive, that's rather obvious, but just showing you the thought process and doing a problem like that if they were not. Putting those signs in the box and then factoring them out sometimes works and sometimes doesn't. So I advise not to put the signs in the box. Now once I have this factored, if I want to find the other zeros, I just set them both equal to 0. So x plus 5 equals 0. X equals negative 5. And 2x plus 1 equals 0. X equals, negative 1/2. So the other zeros in this problem would be negative 5 and negative 1/2. And And before I actually end this, let me just pull out the calculator. Just so we can test the zeros again. There's a couple ways that I can test zeros. And here again, you have ways to go back on the answer. You can just store the number. Oops, the bottom of my calculator seems to be messed up. Let me put it back and start again. There we go. So -5 store x, and then type in 2x cubed plus 3x squared minus 39x minus 20, and that should give me 0, and I can do the same thing by storing -1/2 to see that if that's right. The other thing I can do, though, is I can actually graph the polynomial. Because another thing about a 0 is, since it's a value of x that makes the function or the y value 0, the zeros are the places where this crosses the x-axis. And so if I look at the graph, it doesn't really matter to me at all about what's going on in the graph up and down, so I don't care about the window. The only thing I need to focus on is the x-axis. And if you notice, here it crosses at 4, here it crosses at -5, and here it looks like at least it crosses at -1/2. That's not 100% convincing evidence that it does, but if you're trying to check and you need something a little faster than the store method, that would be a way to do it.